In this video, we're going to look at solving equations using different quadratic methods. And so we're going to start out by just looking at some steps that we would follow. So if the equation is in the form ax plus b squared equals c, then we can use the square root property to solve. Okay. If not, then we can write our equation in that standard quadratic form, always set it equal to 0, and we can try to solve that using factoring. If we can't solve it by factoring, because some things can't be factored, then we can try to use the quadratic formula. Okay. So if we look at this one, we've got x equals the square root of 5x plus 4. So that really doesn't look like anything that we've had before. But we do know that the inverse of a square root, if we were to square that, it would go away. It would cancel that out. And we can do that as long as we do it to both sides. So this square root and this square will cancel each other out. And so that would leave me with x squared equals 5x plus 24. And now I have something that looks like a quadratic. So I'm going to try setting this equal to 0. So x squared minus 5x, so I'm going to move that over. Move that over. So minus 24 equals 0. And now you've got some options. So we could try to factor it if that would factor. Okay. So is there any numbers that would multiply to 24 and add to 5? So we would try, and if we could find some, great. If not, that's okay too. Okay. If we wanted to make our list to see, okay, what would multiply, do a little factoring refresher here, minus 24 and add to negative 5. Right, we've got 1 and 24. Obviously, that one's not going to work. 2 and 12, too big. So 3, let's see, 3 times 8. 1 would have to be negative. We would want the biggest one to be negative. So then if we did 3 plus negative 8, okay, there we go. We've got our negative 5. Okay. So this one actually can be factored. So we've got x plus 3 and x minus 8. And then I could set each factor equal to 0. And x equals negative 3, x equals 8. All right, let's look at this one. So very similar. We're going to start by squaring both sides. So if I square the left, that's 3x times 3x. So that gives me 9x squared. Careful, make sure you don't just square the x. You've got to square that 3 as well. Then here again, this will cancel. So 7x plus 8. Now I want to set that equal to 0. So 9x squared minus 7x minus 8 equals 0. Now, I just think this one looks a little bit tough to factor. I don't like that 9 in the front. So, hey, I'm going to use the quadratic formula just because I think that's what I want to do. So, in this one, my A value is 9. My B value is negative 7. And my C value is negative 8. Okay, remember, no matter which method you choose, you'll always get the same answer. So x equals negative b. So the opposite of b is 7. Plus or minus the square root b squared minus 4 times a times c all over 2 times a. Okay, let's start cleaning that up. So bring down the 7, plus or minus. So 7 squared is going to, or negative 7, sorry, squared, it's going to give us 49. Then I've got 4 times 9 times negative 8. So that is going to give us positive when we multiply it with that negative. So plus 288 over 18. So then I've got 49 plus 288. So I've got 7 plus or minus the square root of 337 over 18. Whew. Now, are there any perfect squares that will go into 337? We got to try, right? So we could say 337. Will 4 go into that? 9. And again, I'm just trying them on my calculator. I'm just doing 337 divided by 9. 337 divided by 16. 337 divided by all these perfect squares that we know, right? And none of them work. So that would be our final answer. Okay. All right. Got a square root, so we've got to get rid of it. We're going to start by squaring both sides. So this one would go away. And on the left, I'm left with 26x minus 13. On the right, I'm left with x plus 6 squared. Remember, that means that you're going to multiply it by itself. So x plus 6 times x plus 6. So we actually have to multiply that out. So 26x minus 13. So that gives me x squared plus 6x plus 6x plus 36. Okay, then we can clean that up and set it equal to 0. So 26x minus 13 is equal to x squared plus 12x plus 36. I'm going to subtract that 26 over. So x squared minus 14x. Then I'm going to add that 13 over to that 36, and that gives me 49. That means I don't have anything left on the left side. Okay. Now this one doesn't look too bad to factor because I want to find numbers that are gonna multiply to 49 and add to negative 14. Okay, so I know that's going to be 7 and 7, but if it's going to be negative 14, I need it to be negative 7 and negative 7. So x minus 7, x minus 7. So that means that x equals 7, x equals 7, but we only have to write it once, right? But that's okay. All right. Okay, so here we've got one, x to the fourth minus 81. So we could factor this, okay? It's a difference of squares. So this would factor into x squared plus 9 and x squared minus 9. But I could factor that even more. Or I could use the square root property. So I could say that x squared plus 9 equals 0 and x squared minus 9 equals 0. And then I could say that equals negative 9. And I could take the square root. And so x equals plus or minus the square root of negative 9, which is plus or minus 3i. Then, same thing here. I would add the 9, take the square root, and so x equals plus or minus the square root of 9, which is plus or minus 3. So I really have 4 answers here because this is 3, x equals 3, negative 3, 3i, and negative 3i. Okay, so this one, we're going to factor it. We're going to look for numbers that multiply to 49 and add to negative 50. Okay, so if we had 1 times 49, that would give me 49, but I need them to be negative, and that would give me negative 50. So if I factored this and did x minus 1 and x minus 49, if I multiplied it back out, I'd get x times x, but I need x to the fourth. So remember, we're going to make these squareds. Okay. Oh, but I could factor those even more. That's a difference of squares. So x plus 1, x minus 1, that, x plus 7, x minus 7. So this is 0, and this is 0, and this one is 0, and this one is 0. So I get negative 1, positive 1, negative 7, and positive 7. All right, so now we've got a fraction. So to solve a fraction, what we can do is multiply by the denominator, the least common denominator. So looking at these, remember we've got x minus 4, and x minus 4. So that means that my LCD is x times x minus 4. So I'm going to multiply everything by x times x minus 4. So each term, x minus 4, x minus 4, x minus 4. And this first one, x's cancel, and I have 1 times x minus 4. Here, my x minus 4's cancel, so I have plus 1 times x. And here, my x minus 4's cancel, so I have x times x minus 3. And we clean it up and solve it. So x minus 4 plus x, and then I have to distribute, so x squared minus 3x. Now I have a quadratic, so I'm going to set it equal to 0. So this is really 2x minus 4. So I'm going to subtract the 2x over. I'm going to add the 4 over. And then that leaves me with 0. So if I'm looking for numbers that multiply to 4 but add to 5, they need to add to a negative 5. Well, I could try 1 and 4, but make them negative. That would give me negative 5. So x minus 1, x minus 4. That means x equals 1 and x equals 4. Remember, we have to always check our answers to make sure it's in the domain when it's irrational. And if I check x equals 4, 4 minus 4, there we go. 4 minus 4 is going to give me 0. Can't have that. So this one is extraneous. So the only solution that I have is x equals 1.